All right, let's get right into it. Right now, everyone, and I mean everyone, is watching NVIDIA, and it's just unbelievable explosion in the AI chip market. But, while all the attention is on the king, there's a really powerful challenger that's quietly starting to change the whole game.
And look, that's a totally fair question, right? NVIDIA seems completely unstoppable. So why on earth are we spending this time talking about Google? Well, because the answer really gets to a fundamental weakness in this whole AI boom and a pretty brilliant solution that could end up reshaping everything. So, to really get what Google's strategy is all about, we first have to talk about the massive challenge that the market leader, NVIDIA, is up against. And honestly, it all boils down to one simple thing: power. Here's the reality. The demand for more and more AI training it's insatiable. To keep up, companies are basically just buying more GPUs and running them harder. But this kind of brute force approach, it's starting to hit a very, very real physical wall.
I mean, to really get a sense of the scale here, we are talking about data centers full of GPUs that can literally use the same amount of electricity as an entire city. Now, that's not just expensive, it's completely unsustainable. It creates a very real risk of just large-scale power shortages. You can't build the AI future if you can't even keep the lights on. So, when you're facing an existential problem like power, what do? Well, Google's answer wasn't to just build a slightly better version of what we already had. No, they decided to build something brand new, from the ground up, for one very specific purpose. And that's where the TPU comes in. It stands for Tensor Processing Unit. And unlike a GPU, this is not a general-purpose chip that was just sort of adapted to do AI. No, this is a highly specialized piece of hardware. It was designed to do one thing and one thing only: handle the crazy matrix calculations, or tensor operations, that are really the beating heart of modern AI. So this comparison really shows you the fundamental difference in their DNA, right? GPUs are incredible, don't get me wrong, but they started their life making video games look pretty. They were repurposed for AI. TPUs, on the other hand, were born for AI, and that specialization, that is the whole ballgame. Okay, so specialization sounds good in theory, but what does it actually get you? Let's get to the head-to-head comparison and see how this all plays out when you look at the metrics that actually matter for building these massive AI models. Wow, the numbers here are just staggering. A GPU is good at AI tasks, no doubt, but a TPU, because it's purpose-built, it delivers roughly 10 times the efficiency. And just look at that power usage. It's not a small improvement. We're talking a revolutionary drop. Let's just pause on that first number for a second. 10 times higher. Efficiency. That means you can get the same job done dramatically faster, or with way, way fewer chips. In the AI arms race, that is a total game changer. And all that efficiency leads directly to this number, a 90% reduction in power consumption. This just solves that power of a city problem we were talking about. It makes building the next generation of AI models actually sustainable and, feasible. Okay, so the tech specs are pretty impressive. But does this actually translate into real-world success? I mean, is anyone actually using these things? Well, the evidence is definitely starting to pile up. The first and maybe most obvious proof point is Google itself. They didn't just design the chip, they bet their own flagship AI model, Gemini, on it. And by training it on TPUs, they achieved top-tier performance on all the major industry benchmarks. That proves the technology works at the absolute highest level. But, maybe the single most powerful validation you can get is when your direct competitor becomes your customer. I mean, as this quote suggests, the fact that Meta has purchased Google's TPUs, that shows real market demand and trust in the technology. You just can't get a better endorsement than that. So, is that it then? Is it game over for NVIDIA? Not so fast. The story is way more complex than that, because the king of the market is not just going to give up its crown without a fight. Yeah, you just don't get to be a market leader like NVIDIA by standing still. They see the landscape shifting, and you better believe they are moving aggressively to defend their turf. NVIDIA is fighting back on every front. Of course, they're developing their own new, more power-efficient GPUs, but they're also innovating on design to get around other performance bottlenecks, like their new work on chips that don't need HBM or high-bandwidth memory. So this isn't a simple succession story, it's a dynamic, evolving war. And that really brings us to the crucial point. If you think about this as just a simple horse race between NVIDIA and Google, you're kind of missing the bigger picture. The incredible demand for AI is lifting all boats, and it's creating this vast, complex, and incredibly valuable AI semiconductor ecosystem.
And so, that leaves us with the ultimate strategic question, doesn't it? In this high-stakes war for the future of computing, do you try to pick the single winner? Or is the smarter move to recognize the scale of this revolution and invest across the entire battlefield?